So in the last video, which I encourage you to watch first, in the last video I talked about completing the square when you've just got a single x squared term. What I'm going to talk about now is what if you don't? What if you've got something like this? 2x squared plus 16x minus 35. Here, you can't make 2x squared into a perfect square. If you have two squares next to each other, it makes a rectangle. 2x squared is not a perfect square. So what you do is you divide the first two pieces by 2. The 35, I'm just going to rewrite because I just don't want to worry about it until the end. So I divided 2x squared by 2, I divided 16 by 2, and I'm just going to do the same thing I did in the previous video, just focusing on this part inside the parentheses. So in the previous video, we talked about how to make a square, you got to have the same amount on both sides. I've got to have 4 x's on either side. So I got to cut the b term in half. Cutting 8 in half gives me 4. So I have x plus 4 times x plus 4. And 4 times 4 makes 16 to complete the square. However, I'm just looking inside the parentheses. And when I look just inside the parentheses, there's no plus number. I'm ignoring the 35 for now. But inside the parentheses, there's no plus number. There's no minus number. So the 16 just came out of the blue. I just borrowed $16 from the bank. If you borrow from the bank, you get a debt. The debt you owe is the same as what you borrowed. That's how debt works. So if you want to pay with a credit card $16, now you also have a negative $16 debt. This all exists inside the parentheses. Double check that everything's accounted for. X squared in the parentheses, x squared in the box. 8x in the parentheses, 8x in the box. There's no number in the parentheses, and there's no number in the box. You borrowed 16 from the bank, you pay 16 back in debt, we're still in balance. We balanced our checkbook. That's a really old metaphor. Nobody uses checkbooks anymore. Well, some people do, I guess. So here we go. We got the 2 and the 35. The 2 and the 35, I'm just keeping track of them on the outsides. The 2 and the 35 are there. So I've got 2. Now I've got an x plus 4 times itself, and I've got a minus 16 because I borrowed 16 from the bank. Take a look at that. Make sure you see where each of the pieces came from. The box that I drew is x plus 4 squared. The minus 16 is what I borrowed from the bank. Now you know what to do. Number outside parentheses distributes to the pieces inside the parentheses. So now we've got our final completed square version. 2 times x plus 4 squared minus 32, because that's 2 times 16, minus 35. Okay, I lied a second ago. I said final. It wasn't quite final. 32 and 35 make 67. So that's our final version right there. Okay. You can complete the square on every quadratic, no matter how nasty of a quadratic it is. The next version, I'm not saying that it's always I'm not saying it's always the best way to do it. I'm not saying it's always the easiest way to do it, just so you can't always do it. I'll show you one more example with even nastier looking numbers just to really drive home the point. So let's say we had negative 3x squared plus 5x minus 1, 2, 3, 4. First thing I'm going to do is divide by negative 3. So I have x squared minus 5/3 x, just leaving the 1, 2, 3, 4 out here. Then I'm going to draw my box. The drawing the box is optional. I've just found it's helpful to remember we're talking about squares. Half of 5/3 is 5/6, by the way. You knew that. So I have to go x minus 5/6, x minus 5/6. The number that completes the square, 5 times 5, 6 times 6. I just borrowed that from the bank, so I'm going to subtract the equivalent amount right there. Negative 3 is still chilling. Negative 1234 is still chilling. So now we have negative 3, big parentheses. We've got an x minus 5/6 squared. We've got a negative 25/36. We've got a negative 12/34. We're going to distribute to give us negative 3, x minus 5/6 squared. Double negative makes positive 75/36 minus 12/34. Last step is just combining these. I'm going to grab a calculator. I've shown off enough with fractions for today. You can use a calculator throughout the whole process. You don't need to be a hero and try to do all your fractions, although it's good practice. So I get this, and that gives me my total completed square version. This ending version is an equivalent graph, equivalent equation to what I started with. So if I wanted to solve or graph the original problem, like if I wanted to know when the original problem equals 0, I can now take my ending version and make it equal 0. And that's where we're going with the next video, is why do we do completing the square? Well, it helps us graph and it helps us solve. It's hard for me to graph the original version. It's hard for me to solve the original version. It is easier, I'm not going to use the word easy, but it is easier to graph and solve the completed square. So that's where we're going in the next video. Again, please comment. Let me know at any time if something's confusing, and I will help out.